Hi, this is tree, there is the sun, and they have nothing to do with each other. Hello, my name is Pavel Savianko, welcome to new Cube video, and in this video I show you another system tree visualization using Sunburst plugin. Let's do it. Okay, we're back into our terminal. And in this video I would like to present you Sunburst plugin, another plugin in our standard distribution. For that we start a cube and open a typical example of a measurement, for example this one. And so first of all, that is the obviously trace measurement, so-called neck bone application, and it was running on machine uQueen. And the first thing what one maybe notice and what is important for us is the system tree or measurement. The size of measurement is relatively large, so it has 16k elements in the system tree. So basically, in total one has around 16,384 threads, and typically one would like to one would like to explore the distribution of the values across the machine, or at least browse them and analyze and take a look at them. So for that one does nothing else and just expand the system tree, so one can see, okay, the measurement was done on machine uQueen, took one rack 53, it took only one midplane, it was running on 8 node boards, and each node board had 32 node cards, and already here we see that it's getting out of the screen, and on every node card was one process is running, and every process was had 64 OpenMP threads. So, and already now one can see pretty soon the problematic in this situation. So as soon as we get deeper in the system tree, we get to our individual values, of course, but we lose overview over the whole system tree. Like for example, if we, I don't know, explore the rank, let's open it like here, rank 128, and we see here value 6 seconds, 6,8 seconds. Is it big? Is it small? Is it larger than others or not? So the fact that we are exploring here local data, let's say, we lose totally the global overview. Of course, one can go into statistics and see the statistical information. Then we would have the global overview, but not local overview, local view on the data, and so it is by such large system trees, it's actually difficult to explore the tree. One can of course go here and take a look, for example, on peer distribution, and in this case the values are scaled and normalized to 1, so their minimal value is mapped to 0 and maximal value to 100, and in this case we see that, okay, the maximal value was, or this is nearly the maximum value. Here is the rather small values are or minimal value. They are not small, they are minimal in this range, in this distribution. So if you take a look at absolute value, it is 6.72, and that's what we call here maximum, so 99%, that is 6.79. So the values are close to each other, but in a distribution. So here is that's maximum, or that is actually here, and here is there was a minimum, and so on. So that is the one way how one can browse and explore the data of system tree, and nevertheless, even in this situation, if one has such local information, such individual values, one loses overview, and even more, one doesn't see any possible patterns or correlations between nodes or elements across the system. So exactly to resolve this problem, we offer another way to display the system tree. We do not use it, display it as a tree, we display it as a sunburst, so-called. That is what makes the Sunburst plugin. So it takes basically the system tree and displays its opening state, like for example here midplane 0 rank is open, these are collapsed, here is open, in a form on Sunburst. Here it is. So as you see, it takes every level and displays it as a circle. So this is the machine, that's highest level, the next level is rec, the another level is midplane, and here we have already sectors because we have individual sectors of the node board 1, node board 2, node board 0, and here is the level of node cards, and then there is a level of individual processes, and here is the level of threads. So, and one can see immediately the level or state of the expanding of the tree. So we have expanded the machine, rec, first and second and fourth node board, and also the corresponding node card. And one can see that the Sunburst displays also peer distribution and the values. So in this case, it displays 0.1%, and here it is 95%. Here it is, where it is, 99.47%, and so on. So, but first of all, controls which plugins offers. So the very first control is the mouse. You can zoom in and zoom out by scrolling up and down. That is one thing. If you press Control and press the left button, then one can rotate the display. If you press Control and press it over the display, no, there it is. Not Control, but Shift. Then you can move it left and right. And if you keep Control and zoom, you can zoom into the one particular sector, like here or here. So if you would like to explore, for example, this element, you can explore it individually, and then it is its size is not related to all other individual sizes. And then if you press right mouse button, you get into context menu, and here various options are available. So for example, frame coloring, it can be black, gray, white, like gray, white. It depends on your color scheme of your display, or no lines at all. So in this case, we take for a black frame. So in order to see the sectors for the expanded levels, we can also choose the color of selection. Like if we click with mouse element, we see here frame. So in this case, it's magenta, or it is here or here, or it might be red, or it might be blue. It depends on your graphic, your preparations. And then if you maybe rotate it a couple of times, you still would like to know from where to which element of the tree which sector belongs to. One can of course hover the mouse and see, okay, that's node board 0, that's node board 2, and this is node board 5. but that is not obvious why here is 5 and here is 0. Because we have rotated this sunburst, but we probably forgot it. So in this way you can display the so-called 0 mark, because the visualization happens starting from 0 and counterclockwise. So in this case, it is like, if it is in this display, we know that these elements are going like this, or if it is like that, then it is going down. Okay. As you see, if you hover the mouse over the element, the windows appeared with information about this element, and totally about the whole system tree. So number of leaves of this element, to which I am holding now mouse, is 2048, starting from MPI rank 16 to 121. It's node board 1, and its value in this state, and that is the collapse state, 94%. It's not absolute value, it's value in this display. And if we hold the mouse here, then it is MPI rank 7, and it has OpenMP threads 48 to 37, and so on. So in this way we can explore actually individual the values across the system tree. But that might be disturbing after a while, so you can hide it and do not display this, this information. You can also hide or show the actual framing over the small arcs. Like, for example, on this level we see that there are no frames, but because we have hidden them, but we can show them, and as a result these arcs are blackened. There is no color black in this scheme, but only because the arcs are so small that the frames are darkening it. If we zoom into this, we see that these are frames here, like for example, but for that one has to zoom in very deeply, and that might be disturbing or not wanted, so we hide these frames into this by small arcs, and we see that it is yellow. As you have seen, you can zoom in towards the place where the mouse is. Like for example here, I'm zooming into this yellow region, or I zoom out from here, or I zoom into this red region, or zoom out from here. That helps in exploration of the sunburst, but it might be annoying or not wanted, so one can zoom towards the center, so it doesn't matter where mouse is, it zooms towards the center of the sunburst. It is, I think, the only matter of taste, of comfort, of control. And of course, some systems have different mouse control, like for example now, zooming, scrolling up leads to zoom out, and scrolling down leads to zoom in. Some systems have it inverted, so if you prefer the differently, you can just explicitly invert zoom, and if you scroll up, you will zoom in, and scroll down will zoom out. That is the possibility to comfort your control of the sunburst. Okay, and of course after a while, if you zoomed in, zoomed out, and you might be lost track whereas you actually sunburst, so you might reset rotation, sizes, zoom state, and so on, or at all everything. The sunburst then jumps in the center, you click one, and that restores the state of the system tree with horizontal with the mark 0 on going to the left, to the right, and with all arc sizes are homogeneous. So that's all about control of the system tree. And now to see maybe how it might be useful, I open another cube file, like for example this one, and oh, it jumps already to the actual place which I wanted to show. So here is also a relatively big system tree, 256 elements, and usually one ends in this situation. So here one can see pretty much 4 nodes, and one sees that this there are like 4 clusters or kinds of the values. If we look in the absolute values, 14, 14, 14, they are relatively close to each other. If you look at the peer percent, they're all around of 99%, so actually distribution is very balanced. And if you look at peer distribution, then one sees that there are 4 clusters which are related to 4 nodes. And again, in this view, one has to scroll up and down, and that might be not comfortable. If you go on Sunburst, you see immediately these 4 nodes, 4 classes of values. One is some middle one, another is round of maximum, this is the minimum. Okay, and so if one goes from metric to metric, for example, one goes here, okay, the same distribution. By computation, it is already more, let's say, homogeneous randomly, as the peer distribution should be. If we take a look at the peer percent, then we see that they all are nearly around of 100%. And in absolute value, they all are. One cannot see any structure in the distribution of the values. Let's stick to the peer distribution first, and then if we go to another metric, like for example MPI metric, we still don't see any structure here. But if you go to another management, one can see clearly the 4 nodes. Synchronization, one can see that the rank 0 in a corresponding node has the shortest time for synchronization, so the others are taking a long time, and communication is also kind of without structure. So if we take a look at the synchronization itself, we see that here is weight of barrier, and here is the barrier completion has already different structure. So here is the all large values, and here is the smaller values. We can go across the system tree and take a look what's going on here, and we see here that is the barrier that delivers the structure. If we go to weighted barrier, we suddenly see here a nice rainbow, which states basically that our rank 0, I have to show tooltip here, rank 0 has the lowest waiting time for the MPI barrier, but rank 1 has the highest time, and continuously decreasing towards the MPI rank 255. That might indicate the property of the measurement. So it's obviously the higher ranks are waiting least to complete barrier, so they may be entered this barrier, the barrier later, or that might be a problem of MPI implementation. Let's take a look. Maybe some another calls have very same structure. So this MPI barrier doesn't have this structure, so probably it is not the problem of the MPI implementation. This barrier is like this. Okay, so what's about synchronization? Communication. So let's take a look at communication. Reduce has no structure, but for example receive has this structure, so that might be has something to do with each other. So here is obviously the rank 1 which has the shortest receive time, rank 2 is the next shortest, and so on, and rank 255 has the largest receive time. In barrier completion it is opposite, so maybe this pattern has something to do with each other. Let's take a look at the gather. Broadcast here has the same property, and so on. So as you have seen, having such a global overview over the system tree helps you to understand the measurement better. because in such detailed view one is lost in local information and probably doesn't have a possibility to see such patterns on a global level, and statistic will not give you this possibility as well, even if it is a violin plot. So I hope you you understood how the Sunburst plugin works, how it visualizes system tree, and how it might be useful in your performance analysis. And if you have any questions, write them in comments, press a like, subscribe, and see you next time.